Hey everyone, today we're going to start chapter 3 and we're going to start the last section, which is learning how to do conversion problems. When we get later into chemistry, we're going to have to learn how to convert between different things. For example, my advanced chem class is learning to convert between mass of a compound to atoms of a compound. So we do this by teaching you simple dimensional analysis first. So let's go ahead and get started. This beginning question says, how can you convert US dollars to euros? And because each country's currency compares differently to the US dollar, it's important to know how to convert between different currency units. Especially if you go up to a booth and you buy something and they're making you change, you want to make sure you're not getting ripped off. Conversion problems are an easy way to convert between different units, and we use an approach called dimensional analysis, which is slightly different than basic algebra you guys learn in math class. If you think about any number in everyday situations, you can have a quantity of something and express it several different ways. Money is the easiest example to work with because you guys have worked with money since you were little children. For example, if I give you $1, I can hand you one single dollar bill, 4 quarters, or I can give you 10 dimes, 20 nickels, or 100 pennies. No matter which amount I give you, all of it is the same amount of money. It's worth the same. One thing to note, and I'm going to point this out here, notice my smallest unit, such as pennies, gets the biggest number. My biggest unit, dollars worth the most amount, gets the smaller number. Same thing is true of any scientific quantities that we work with. For example, we looked at prefixes a week or so ago. If I said 1 meter, that's same thing as saying 10 decimeters, or same thing as saying 100 centimeters, or 1,000 millimeters. They're all exactly the same length. The only thing that changed was my unit that I'm using, so my number changed. Now, whenever two measurements are equivalent, and all that means is that they're equal, the ratio of those two measurements will equal 1. So for example, you can divide both sides of the equation by 1 meter equals 100 centimeters by 1 meter or 100 centimeters and still equal 1. So here's a conversion factor. And here's also another conversion factor just flipped. Since these are the same quantity, it's like saying 4 divided by 4. Anything divided by itself is 1. Now, these ratios that I showed you on the last slide, 100 centimeters and 1 meter, these are called conversion factors. And again, they're just a ratio, and that ratio means it has this little division line, and they're equivalent measurements. They mean the same thing. For example, here, these are the exact same length. These aren't the only conversion factors. You know them in all everyday life. For example, some ones that are common that you may know is there are 60 seconds and 1 minute. Another way that you can express it is you can say there are 60 minutes and 1 hour. Let's say 24 hours is in 1 day. Or you can even say 365 days in 1 year. They mean the same thing, they're equivalent. These are all conversion factors. Another example of conversion factor besides using things for time are, hopefully in elementary school you learned that there were 12 inches in 1 foot, or there are 3 feet in 1 yard. These are common conversion factors we use all the time. Now notice the measurement in the numerator on top is equal or equivalent to the measurement in the denominator on the bottom. And the way that we read these is per for that little bar. So for example, on this conversion factor right here, we read it as 100 centimeters per meter. Or over here, we can say 1 meter per, that's what the little line means, 100 centimeters. Now, I did kind of hit on this earlier in the lesson, but we're just going to bring it back up and it will be in your notes. The figure up above illustrates a way to look at the relationship between your units and your number. Note, the smaller of the two units, so centi is smaller than a meter, is going to get the larger number because it takes more of them to make up. Here, my larger unit, which is meters, is going to get the smallest number. Same thing happens with seconds and minutes. It takes way more seconds to equal 1 minute because minutes the bigger unit. So why do we learn about them? Well, conversion factors are useful in solving problems where we're given a measurement, but we want to change it to some other unit. For example, if you are given 4 days and you want to know how many hours that is, you can solve that. So what happens if we take a measurement and we multiply it by a conversion factor? So say, for example, we take those 4 days and we multiply it by a conversion factor that we know. For example, we know that there are 24 hours in 1 day. Well, when we do this, we will know that there are 96 hours. When we multiply it by this conversion factor, and we're going to put this on the next slide as well, 4 days and 96 hours, the number changed. My unit changed, but what didn't is the actual amount of time. It's still the same. So when a measurement is multiplied, while the numerical value changed, for example, 4 changed into 96, the actual size of the quantity, so the amount of time, is still the same. If I said I will be there in 4 hours or 4 days, that's same thing as saying I will be there in 96 hours. Down here, the example the book uses is if I say 1 gram, it's the same thing as saying 10 decigrams. They both mean the same mass. So many problems in chemistry we want to be able to convert between different units. And instead of using algebra, we use something called dimensional analysis. And this is defined as a way to analyze and solve problems using our units or our dimensions. And the whole point of it is to cancel our units that we have. So we're going to work through an example here on the next slide to help us solve an everyday situation. Our example is going to be how many seconds are in a workday that last exactly 8 hours. So here, this question tells us that we're looking for seconds. This is what we want to get to. And we're starting with hours. So we want to somehow get from our hours to our seconds. If you're ever given a conversion problem, you need to start with something that you know. And so here we're starting with our 8 hours because that's what was given to us in the problem. Now, hopefully you guys all taken an algebra class and know that in order to cancel units, they have to be diagonal from each other or on opposite sides. So this is considered to be the top. In order to cancel hours, it needs to be on the bottom. So I'm going to write this up here. To cancel units, they must be opposite. Please add that to your notes if you're one to likely forget that. Now, I don't know a conversion between hours to seconds, so we need to break this down. We can actually take hours to minutes first and then take minutes to seconds. So if we were going to break this down from hours to minutes, there's a relationship that we know there. For example, we know that there are 60 minutes in 1 hour. This allows me to cancel hours as my unit, and now we're at minutes. But I want to get to seconds, so I need to do another conversion. In order to cancel minutes, since it's on the top here, opposite, it needs to go on the bottom. So I'm going to say minutes on the bottom, and I'll put seconds on top. And ask yourself, is there a relationship here? Yes, there are 60 seconds in 1 minute. That allows me to cancel my minutes, and now I'm at my seconds. That's exactly what I wanted since it's asking how many seconds. Then you plug it into your calculator. Most often question I get is, what do I plug in? Well, if the number is on the top, you multiply. If the number is on the bottom, you divide. And if it's a 1, you don't have to worry about it. So this would be read as 8 hours times 60, because it's on top, times 60 over here, because it's also on top. So when you plug in 8 times 60 times 60 in your calculator, you should get 28,800, and don't forget your unit, which is seconds. If you're struggling with this, please make sure that you guys come ask for help. This is the setup I'm going to expect to be on your guys' homework. Don't solve it algebraically. I want to see this setup and crossing out. So let's work through another example. This one says the directions for an experiment asks each student to measure 1.84 grams of copper, which is abbreviated Cu. The only copper wire available is a spool with 50 grams, and it wants to know how many students can do the experiment before the copper runs out. You need to ask yourself, what are you trying to get to, or what are you trying to find? Here, it's asking for how many students. So that's what I'm trying to get to, is students. And here I need to ask myself, well, students have a relationship to what? It's going to show up here that each student can get 1.84 grams. So I'm starting with grams. This sentence that I underlined up here is considered a conversion factor. When you hear the word each, you're thinking of a single student. So you can say one student equals 1.84 grams. So if I'm going to do this problem, I know that I have 50 grams. And I need to get over to students. So in order to cancel units, grams needs to go on the bottom. And do I have a way to get to students? I do. Up here, one student is 1.84 grams. So one student is 1.84 grams. This allows me to cancel my grams, and I'm left with student on the top, which is exactly what I wanted. Note here, if you're going to plug this into your calculator, 1.84 is on the bottom. So 50 divided by 1.84 in your calculator, you should get 27.1739. Unfortunately, you can't have part of a student. We're not dismembering kids here and cutting off arms. So we need to round down since you can't make more students. So 27 students are able to do this experiment. The last thing we're going to work through is if the exchange rate between US dollars and euros is 0.7 euro to every dollar, what is the conversion factor that allows you to convert from dollars to euros? This ties us back into the beginning of why we learn conversions. Here, this statement says 0.7 euros to every dollar. So we know that 0.7, that's not 0.7, 0.7 equals $1. So 0.7 euros. When we write conversion factors, you can write it as 0.7 euro over $1, or you can say $1 over 0.7 euros. Those are two conversion factors you're allowed to have. Now we have to figure out which one would we use if we're starting with dollars and we're trying to get 2 euros. So if you're starting with dollars, the conversion factor we would want to use is ones that cancel this unit. Remember what we put a few slides ago. Units have to be opposite. So we would want dollars on the bottom and euro on the top. So the conversion out of the two that we have that has euros on top and dollars on bottom is this one. So what conversion factor? 0.7 euros per $1. And that's the end of today's lesson. If you have any questions, please make sure you ask. And otherwise than that, have a great day.